Hello guys, welcome back to my channel Algorithm Avenue. In this video, we'll be discussing an important concept called backpropagation algorithm. Okay, in our previous videos, we have already discussed few concepts like forward propagation and gradient descent algorithm in detail. Okay, these concepts are foundational concepts for understanding backpropagation algorithm. As we have already completed those these foundational concepts, now we are ready to go with backpropagation algorithm. Okay. Now, to understand this backpropagation algorithm, I'll give you a simple example. Now, let's say your mother has given you a list of items to go and purchase in the market. Now, what you will be doing is you'll be taking that list of items, okay, list of items, and you'll be going to the supermarket and you'll be purchasing those items and come back to home. Okay, when your mother compared the list of items to the items what you have bought, your mother observes that some items are wrongly bought. Okay, now what your mother says to you to go and bring the to go and change to go and return them and bring the items in the list. Okay, now what you will be doing, you'll be going to the supermarket and update those items. Okay, update those items and come back home. Okay, now what you are doing here, what the items you have bought wrong, okay, those items you are going back and updating. Okay, this step is called back propagation. Okay, you're back propagating. Okay, you're back propagating and updating your parameters. This is called back propagation algorithm. Okay, basic concept of back propagation algorithm. Now let's see the basic definition of back propagation algorithm. The backpropagation algorithm is a technique to train an artificial neural network. Okay, this is a simple definition of backpropagation algorithm. Okay, backpropagation algorithm is an technique. Okay, it's a technique to train an artificial neural network. What you will be doing in this backpropagation algorithm is you'll be finding optimum weights and bias values. Okay, you'll be finding some optimum weights and bias values which will be making the correct predictions. Okay, which will be making the correct predictions by minimizing the loss function output. Okay, this is the basic concept of back propagation algorithm. Okay, now to understand this back propagation algorithm, I have taken a corresponding sample data set which has two features in it, that is rooms and sft, and corresponding output, true output, that is price, and it is represented by yi. Okay, now these two features, okay, these two features are represented by xi1 and xi2. Okay, these two features are represented by xi1, xi2, and yi is the true output. Now what I'll be doing is have designed an artificial neural network which works well on this dataset. Okay, I have designed an artificial neural network which works well on this dataset, which contains two layers. Okay, it is a two-layered artificial neural network. Okay, this is my first layer and this is my second layer. This is a hidden layer and this is the output layer. Okay, I'm giving an input. Okay, I'm giving an input, that is xi1 and xi2, and these are my weight parameters. Okay, these are my weight parameters. Okay, I have already told you how to denote the weights and biases, weights, bias, and outputs in my previous video. If you didn't watch the video, please go and watch. Okay, these connections, okay, these connections correspond to weights, and each node will be having a bias and corresponding output. Yes, now now what you will be doing is you will be sending the first row of data. Okay, first row of data into the neural network. Okay, before sending the first row of data into the neural network, what you will be doing is you will be assigning random values. Okay, random values to this weights and bias parameters. Let's say the values may be random, or you may also take the values as weights is equal to 1. Okay, you will be taking all the weights as 1 and bias as 0. Yes, this is the assumptions you are considering for this trainable parameters. You may also go with random values, or you can take weights values is equal to 1 and bias values is equal to 0. Now, after considering these assumptions, I am sending my first row of data into the artificial neural network that I have designed. Now, my first row of data goes into the neural network with the help of forward propagation. Now, through forward propagation, what will this y hat is the predicted output for this first row. Yes, this y hat is the predicted output for this first row, and this is the true output. As this is a linear regression problem, I need to have a loss function, that is MSE loss function. Okay, mean squared error loss function, that is represented by loss function is equal to y minus y hat. y minus y hat whole square. This is the corresponding loss function I am considering. Okay, it measures the magnitude of error that my neural network has made between the true output and predicted output. Yes. Now, when I calculated this y minus y hat whole square, initially, in the initial stages of training, it will be definitely higher. Now, what is my end goal is to minimize this loss function output. Okay, I should minimize as low as it can. Okay, I should be minimizing this loss function value. How can I minimize this loss function value? Now this y is fixed value. Okay, y is fixed value. Now I have the only option is to change the y hat value. How can my y hat value be changed? Y hat is indirectly dependent on these parameters. Okay, y211, y211, b21, and w2 w221. Okay, this y hat is indirectly dependent on these trainable parameters. Means indirectly, to change this y hat value I need to update this weights and bias values. Okay, I hope you are getting right. To minimize this loss function value, I cannot change this true output because it is already given in data. Means it is fixed value. So I need to alter this y hat value. To alter this y hat value, I have the only option is to change this trainable parameters. So when I change, means at the time of training, at the each row I need to update this weights and bias parameters. Right, I need to update this weights and bias parameters, and my goal is to find the optimum weights and bias parameters. Right, now I need to indirectly uh, access these parameters through this y hat parameter. Okay, through this y hat output. Yes. Now in the next section of the video, I'll be showing you a graphical representation how from here you'll be going till here. Okay, from just considering this y hat, you'll be indirectly accessing these trainable parameters. Okay. Yes, as I was specified in the previous section of the video, I'll be showing you a small tree diagram to understand the how this y hat value is updated. Okay, in my previous section of the video, I have already told you that to minimize this loss function, I have the only option is to change the y hat value. Now, indirectly, you can see that y hat value is dependent on many trainable parameters, right? Now, let us see on how many parameters this y hat value is indirectly dependent. Okay, now y hat is nothing but O to 1, right? Yes, this node output is equal to y hat, right? The output prediction of this node is equal to y hat value. Yes, now to alter this y hat value, what are the options I need? What are the options I have? First, I'll be changing this bias value, right? First, I'll be changing this bias value, that is b to 1. To change this y hat value, first in my back propagation step, okay, in my back propagation step, what I will be encountering this bias value, right? First I'll be changing this bias value. Next, this node output, okay, this node has two connections, right? This node has two connections, that is w211 and w221. Next I'll be changing w211 and w221. Okay, now this is the output of this node and this is the output of this node. Now to change this value, to change this entire value, I need to change this predicted outputs, right? Predicted outputs of this node and this node. Okay, to just change this value of this node, to change the value of this node, I need to also change this o11 and o12, right? Next, o11 and o12. Okay, now initially we have started from O to 1, and through back propagation step, first I have reached my B to 1. Next, from B to 1 I have reached W to 11. Next, this corresponding connection W2 to 1. Now these are the predicted outputs of this nodes, that is O11 and O12. Now I'll be considering this node. Okay, I'll be considering this node, that is O11. To change this output predicted value of this node, what can I change? I can change first this bias value, that is B11, and next corresponding to this I have two weight values. Okay, to change this output, O11, first I'll be changing this bias value, that is B11. To after changing this B11 value, I need to update my parameters again, that is weight values again. what are the corresponding weights that are associated with this node, that is w111, w111 and w111. Okay, also these weights are associated with my inputs. Okay, I'm also writing my inputs, that is xi1 and xi2. Okay, now when it comes to o12, similarly I'm going with o12. Okay, we have considered o11 and reached till here. Now I need to consider my o12. So corresponding to o12, first I'll be encountering b12. Right, first I'll be encountering b12. First I'll be changing my b12 parameter. Now corresponding to b12, corresponding to this node, I have two connections, that is two weight values, that is w112 and w122. Okay, I'll be also changing these values, these weight values, right, w112 and w122. Okay, initially we have started from here, and through back propagation we have updated this bias value, and we have also updated this weight values. Okay, after updating this weight values, to change this output values, I need to first consider this bias values and corresponding to this weight values, and also in calculating this O11 output, this xi1 and xi2 are indirectly involved. So I am also writing xi1 and xi2. Okay, we have started from here and we have reached till here. Means you can see an indirect relationship, right? You can see an indirect relationship. I'm starting with y hat and go with the help of back propagation, I have reached till here. Yes, this is the entire tree diagram corresponding to this neural network. Okay, now how can I update this weights and bias parameters? With the help of weights and bias updation formulas. What are the formulas? W nu is equal to, I have already explained you previously, W nu is equal to WL minus learning rate del L by del WL. Okay, this is the formula. I have to update my weight value, and B new is equal to B old minus learning rate del L by del W old. Okay, these are the corresponding formulas I have to update this weight values and bias values, so that I can get the optimum values of weights and bias. Okay, in the next section of the video, I'll be showing you how the back propagation updates this weights and bias values with this formula. Yes, in our previous section of the video, you have seen a small tree diagram on how there is an indirect relationship between y hat and the trainable parameters and the inputs xi1 and xi2. Okay, you might have probably understood the indirect relationship between this y hat and trainable parameters. Right now, in this section of the video, we will be determining how back propagation mathematically updates the value of this weights and bias values, right? Okay, now initially we'll be having a small discussion on this weight updation formula and bias updation formula. Okay, now when it comes to weight updation formula, W nu is equal to W old minus learning rate dou L by dou W old. Okay, in this formula you already have W old value. Okay, as you initially start with random values or initialize weight with 1 or 0, you already have the W old value. Okay, you already initialize the learning rate, but what is the value you have to determine is this gradient value. Okay, that is dou L by dou W old. Okay, when it comes to bias updation formula, b new is equal to bias new is equal to bias old, which is already taken as random or as value of 0, b old minus learning rate and dou L by dou W old, sorry, dou L by dou B old. Okay, this is the value of gradient. Okay, you don't know the values of this gradient and this gradient. Okay, now your end goal is to find the values of these gradients for each of the node, so that you can update the values of W new and B new. Okay, W new and B new. Okay, now by understanding the calculation of these gradients, you will be also understanding how the back propagation steps are taken in the back propagation algorithm. Okay, now as it is an linear regression problem, I'm taking MSC loss, that is L is equal to y minus y hat whole square. Okay, now we'll start our discussion with the calculation of these gradients. First, when you are back propagating, to minimize the value of loss, you initially start from y hat, right? Okay, your starting step is to minimize the value of y hat. Okay, to change the value of loss function, you need to change the value of y hat. So you start from y hat. When you start from y hat and back propagate, initially what you encounter is b to 1. Okay, bias to 1. Okay, bias with respect to this node. First we'll be considering this node. Okay, we'll be considering this node. With corresponding to this node, what are all the trainable parameters we have, will be determining gradients of those trainable parameters. First, when corresponding to this node, what are all the gradients we have, we'll be writing it over here. First is dou L by dou B to 1, comma, corresponding to this node, what are the values of weights we have? These are the values of weights we have corresponding to this node, right? That is W211 and W221. Okay, now I need to also determine the value of gradient for these weights as well. Dou L by dou W211, comma, dou L by dou W221. Okay, with corresponding to this node, I have written all the gradients of all the trainable parameters. Okay, now we'll be determining the gradients of this node. Okay, we'll be determining the gradients of this node. Now when it comes to this node, we'll be determining the gradients. Okay, that is dou L by this node as a single bias, dou L by dou B11, comma, what are the weights associated with this node? We have two weights associated with this node, that is W111 and W121, right? We'll be also determining the gradients of this weights, comma, dou L by dou W121, right? I have also written the gradients corresponding to this node. Now I have to select my third node, that is this node. Okay, now I have to write all the gradients of this node. When it comes to this node, I have a corresponding bias and also corresponding weight values, that is W112 and W122. Okay, now I'll be writing the gradients for this trainable parameters, comma, dou L by dou W112, comma, dou L by dou W122. Okay, I have written the all the nine gradients corresponding to each of the node. Okay, corresponding to each of the node. Now my aim is to calculate each value of this gradient. Okay, each value of this gradient. Okay, how back propagation algorithm internally calculates the value of these gradients. Similarly, the same mathematical procedure we will be following and calculate the values of these gradients. Okay, now let us start with calculation of this gradient. Okay, let us start with calculation of this gradient. Okay, before starting with calculation of this gradient, what we'll be doing is I'll be explaining a small indirect relationship. Okay, first to change the value of loss, we have the only option is to alter the value of y hat, right? Means loss is directly dependent on value of y hat. Okay, loss is directly dependent on y hat. Now y hat is directly dependent on what are the values? That is, okay, the value of y hat is dependent on what values? The value of b21, value of w211, and value of w221, right? Now I'll be also writing the values of them. B21 and W112 and W221. Okay, loss is dependent on y hat, loss is dependent on y hat value is directly dependent on bias B21, weight W211, weight W221. Okay, now you can see that loss is indirectly dependent on the trainable parameters. Okay, loss is indirectly dependent on the trainable parameters. Loss is directly dependent on y hat is directly dependent on these three trainable parameters, but loss is indirectly dependent on these three trainable parameters. Okay, now corresponding to this indirect relationship corresponding to this indirect relationship we'll be rewriting the equations. Okay, we'll be rewriting this derivative value. Okay, sorry, we'll be rewriting this derivative value. Okay, now let's start with this value, dou L by dou B21. Dou L by dou B21 is equal to we'll be following this path. Okay, we'll be following this path. First, loss y hat B21. Okay, dou L by dou B21 is equal to dou L by dou y hat. Okay, dou L by dou y hat, loss is indirectly dependent on y hat, and sorry, loss is directly dependent on y hat, and y hat is directly dependent on B21 bias. Okay, now when you cancel up this dou y hat and dou y hat, you'll be having the same derivative, right? Okay, now I have established this indirect relationship. Okay, I have established this indirect relationship into two direct relationships. Okay, now let us calculate this derivative values individually. First, we'll be starting with del L by del del sorry dou L by dou y hat. Okay, now when it comes to dou L by dou y hat is equal to dou y hat, what is the value of loss? Loss is equal to y minus y hat whole square. Okay, y minus y hat whole square, y minus y hat whole square. Okay, now dou L by dou y hat is equal to dou into, I have rewritten the value of loss is equal to y minus y hat whole square. Okay, dou, now let us try to differentiate this derivative. Okay, this is equal to differentiation of x square with respect to x. It is 2x, right? Differentiation of x square with respect to x is 2x. So same formula I am applying it over here, right? This is equal to 2 into y minus y hat. After calculating the derivative of x square, you also independently calculate the derivative of x, right? So this comes out to be minus 1 minus y hat derivative. So the derivative value of y hat is equal to minus 1. Okay, so the value of dou L by dou y hat is equal to minus 2 into y minus y hat. Okay, now we have successfully found out the derivative value of this. Now let us find the derivative value of this. Okay, let us find the derivative value of this. Now dou y hat by dou B21. Okay, now what is the value of y hat? From this you can see that what is the value of y hat. Okay, I'll be showing you a small neural network. Okay, this is a single node, this is a single node, and corresponding to this we'll be having two inputs, that is x1 and x2. Corresponding to this inputs we'll be also having the weights, that is w1 and w2, and this is the bias b1, and this is the y hat predicted output. Now what might be the value of y hat? It is the multiplication of this input to this input added to this input to this weight and added with bias value. Right, now this can be written as x1 w1 plus x2 w2 plus b1. Okay, this can be written as in this way. So similarly, this similar rule I am applying it over here. Okay, now the value of y hat comes out to be dou B21. Now the value of y hat comes out to be multiplication of this output. Okay, this the node output, sorry, the output of this node is O11. Okay, this will be the input of this node to this node, and the output of this node will be the input of this node, means O11 and O12 are x1 and x2 values. So okay, sorry for the interruption. Okay, now the value of y hat is the multiplication of O11 with W211 added with O12 plus O12 into W221 added with bias B21. Okay, now I am writing the same equation over here. That is O11 W211 plus O12 W221 added with bias B21. Okay, now I need to determine the derivative of this equation with respect to B21. Okay, now the derivative of this equation with respect to B21 is the value of this is equal to 0 with respect when it is partially derivated with this value B21. Now this is equal to 0 and the derivative of x with respect to x is 1. So the derivative of B21 with respect to B21 is 1. So the final equation will be multiplication of minus 2 into y minus y hat into 1. Okay, now means the final output of this dou L by dou B21 is the multiplication of this individual derivatives. So the individual derivative of this is minus 2 into y minus y1, sorry, minus 2 into y minus y hat, and the individual derivative of this is 1. So I need to multiply these both derivatives to obtain this derivative. So dou L by, I'm drawing a line over here, dou L by dou B21 is equal to minus 2 into y minus y hat. Okay, this is the final equation. Okay, this is the final derivative value of dou L by dou B21. Okay, we have successfully obtained the value of this derivative. Okay, now our next step is to obtain the value of this derivative, that is dou L by dou W211. Okay, dou L by dou W211. Now dou L by dou W21 means you choose this path, right? In calculating dou L by dou W211, you choose this indirect path. Okay, now corresponding to this indirect path, we'll be rewriting the same equation over here, sorry, same derivative value over here, that is dou L by dou W211 is equal to, as this is an indirect relationship, I am writing it as a multiplication of two direct relationships, that is dou L by dou y hat and dou y hat divided by dou W211. Okay, dou L by dou y hat multiplied by dou y hat divided by dou W211. Okay, now the derivative value of this is equal to dou L by dou y hat multiplied by dou y hat by dou W211. Now let us try to determine the value of this derivatives. Now dou L by dou y hat value is similarly we have calculated here, that is minus 2 into y minus y hat. Okay, we have already determined over there, so I'm again not recalculating it. Now we have determined the value of this derivative. Now let us try to determine the value of this derivative. Okay, the value of this derivative comes from same equation. Okay, comes from same equation, but here you have determined with respect to B21, you have calculated the partial derivative with respect to B21, but instead of this B21 you need to calculate the partial derivative of W211. Okay, with respect to W211, when you calculate the partial derivative with respect to W211, it comes out to be, this will be 0, this will be 0, and the partial derivative of 2x with respect to x is 2, right? So similar relationship. Okay, similarly you determine it over here, which comes out to be O11. Okay, this is the value of this partial derivative. Okay, this gradient value is minus 2 into y minus y hat into O11. Okay, we have successfully completed the two calculation of two derivative values. Now let us calculate the final derivative value that is associated with this node. Okay, now dou L by dou W2 to 1 is equal to, now you follow this path, this indirect path. Okay, this is the indirect path that you follow to calculate the value of this derivative. And this indirect derivative, I'm writing it as multiplication of two direct derivatives, which comes out to be L by dou y hat into dou y hat by dou W2 to 1. Okay, which comes out to this. Now I need to determine the derivative, individual partial derivatives of this. So this comes out to be, I have already calculated this dou L by dou y hat, which is minus 2 into y minus y hat. And now I need to determine the value of this derivative. Okay, the value of this derivative. This derivative comes out from this equation. Okay, this derivative comes out from this equation. Here you have done with B21, but here you need to calculate with respect to B2 to 1. Okay, W2 to 1. Okay, when you try to determine with respect to W2 to 1, this comes out to be 0, this comes out to be 0, and this comes out to be in the form of derivative of 2x with respect to x is 2. Okay, similarly I'm writing it over here, that is O12, and this is the final derivative value. Okay, with respect to this node, you have successfully completed the calculation of all the three derivative values. Okay, all the three gradients. We have first calculated the value of this derivative, that is over here, and next we have calculated the derivative value of this over here, and the gradient value of this over here. Okay, corresponding to this node, I have successfully completed calculation of all the three derivatives. Now in the next section of the video, we'll be covering this node. Okay, we'll be covering all the derivative values corresponding to this node. Yes, in our previous section of the video, we have successfully seen how to calculate the gradients corresponding to this node. Now let us calculate the gradients with respect to this node. Okay, what are all the gradients that are corresponding to this node? That is, the first gradient value is dou L by dou B11. Okay, the second gradient value that is corresponding to this node is dou L by dou W111. Okay, the third gradient value that is corresponding to this node is this weight value, that is dou L by dou W121. Okay, these are all the three gradients that are corresponding to this node. Okay, now let us determine the values of this each gradients individually. Okay, first let us try to calculate the value of this derivative value. Okay, before going to calculate this derivative value, we have to see an indirect relationship between y hat and this node. Okay, now let us see an indirect relationship. First this is, okay, first I'll be writing my loss. Okay, my main aim is to minimize the loss. How can my loss be minimized? It can be minimized with the help of value of y hat. Okay, now y hat is dependent on O11 and O12, right? Y hat is indirectly dependent on O11 and O12, right? O11 and, okay, as I'm calculating the derivative only with respect to this node, I'm writing O11. I'm writing just O11. Okay, it is actually dependent on both this O11 and O12, but as I'm considering only this derivative, okay, as I'm considering only this node for now, I'm considering only O11. Okay, now the value of this O11 is dependent on three trainable parameters. Okay, that is B11 and the corresponding weights with respect to this node, that is W111 and W121, right? First you start with minimizing the loss. The loss is minimized with the help of y hat, and y hat is indirectly dependent on O11 input and O12 input. As I'm considering only this node, I'm taking O11, and O11 is indirectly dependent. Okay, O11 is directly dependent on B11 and W111 and W121. Okay, now this is the indirect relationship I have between loss and this trainable parameters. Okay, now let us try to calculate the each gradient value. Okay, first I start with del l dou l by dou b11. Okay, dou l by dou b11 is equal to, I follow this path, this indirect path for calculation of this gradient. Okay, that is dou l by dou y hat into dou y hat by O11 into O11 dou O11 by dou B11. Okay, this is my multiplication of three direct paths. Okay, I'm representing my one indirect path with multiplication of this three direct paths. Okay, now let us try to calculate the three derivative values. Okay, we already know this derivative value, that is derivative of loss with respect to derivative y hat. Okay, y hat, that is minus 2 into y minus y hat, right? Now we'll be calculating the derivative values of this both. Okay, first let us calculate dou y hat by dou O11. This comes out to be, we already know y hat equation. Y hat is equal to O11 W211 plus O12 W221 plus B21. Okay, dou by dou O11, this is partially derivative with O11 W211 added with O12 W212 plus the bias term, that is B21. Okay, now we'll be calculating the partial derivative with respect to O11. As you are calculating with respect to O11, this derivative value, this value becomes 0, this value becomes 0, and the derivative of x with respect to x is, sorry, the derivative of 2x with respect to x is 2, right? This comes out to be, W211. Okay, now we have successfully determined the derivative value of dou y hat by dou O11. Now let us try to determine the value of dou O11 by dou B11. Dou O11 by dou B11. Now the same formula follows over here. Okay, here we have taken the output of this node, that is y hat multiplied by, okay, that is y hat multiplied by O11 into W211 added with O12 W221 added with B21 bias. Okay, similarly for this node output, that is O11 which comes out to be, the multiplication of this input, with respect to this weight, that is xi1 into W111 added with xi2 into W121 added with bias B11. Okay, now the partial derivative with respect to B11 is, this comes out to be 0, this comes out to be 0, and this comes out to be 1, right? The derivative of x with respect to x is 1, so this is the value of this partial derivative. Okay, now let us finally write the equation. Okay, let us finally write the final output of this gradient value, that is dou l by dou b11 is equal to, which is multiplied by three direct relationships. Okay, three direct relationships, that is dou l by dou y hat is equal to minus 2 into y minus y hat. Okay, this is multiplied with this weight value, that is W211, and this is multiplied with 1. Okay, I'm not representing over here, this is the entire gradient value. Okay, this is the entire gradient value. Now as we have calculated, as we have successfully calculated the value of this gradient, now let us determine the value of this gradient as well. Okay, that is dou l by dou W111. Okay, here we'll be following this path. Okay, here we'll be following this path. Now this comes out to be the direct relationship. Okay, the direct relationship of loss with respect to y hat and d dou y hat by dou o11 multiplied with dou o11 with respect to w111. Okay, now here I need to determine the three derivative values. Okay, three partial derivative values. I have already know this value. I need to calculate these two derivative values. Similarly, how I have calculated here, the similar way I'll be calculating it over here. That is minus 2 into y minus y hat. Okay, the value of this derivative. Now dou y hat by dou o11 comes out to be yes, this equation. Okay, this equation I need to derivate. Okay, I need to find the partial derivative of this equation with respect to o11. Okay, here I determine with respect, sorry, here I have determined with respect to o11. Similarly, I'll be determining with respect to o11. That comes out to be w211. And now I need to find out this derivative value. Okay, I need to find out this derivative value with respect to dou w11. Okay, w111. Here I have partial derivative with this b11. Now here I need to derivate with respect to w111. Okay, now this will be equal to 0, this will be equal to 0, and the value of derivative and the partial derivative of 2x with respect to x is 2, right? Similarly, I'll be writing it, the partial derivative of xi1 multiplied with w111 with respect to w111 is xi1. Okay, is xi1. This is the value of gradient. This is the value of gradient of this dou L by dou W11. Now we'll be calculating the gradient value of this dou L by dou W121. Okay, dou W121 is equal to same indirect path that is corresponding to this weight. Okay, now we'll be following this path. Okay, we'll be writing with the multiplication of three direct paths. Dou I hat by dou o11 multiplied with dou o11 by dou w121. Okay, similarly, I know the value of this. I have already calculated the value of this over here, that is w211. Okay, I am writing it over here, minus y hat into w211. Now I need to determine the partial derivative of o11 with respect to w121. Okay, I have this equation. I already have this equation here. Instead of b11, I need to partially derivate with respect to w121. Okay, when I do the partial derivative of this equation with respect to w121, this comes out to be 0, this comes out to be 0. The left out term is this. Okay, I need to do the partial derivative of xi2 multiplied with w121 with respect to w121. This comes out to be xi2. Okay, this comes out to be xi2. This is the final value of this gradient, that is dou L by dou w121. Okay, we have successfully determined 6 derivative values till now, and the leftover three derivatives will be calculated in the next section. We have completed in our back propagation mathematical intuition till this part. If we complete this part, we will be entirely understanding how this back propagation will work. Okay, yes, in our previous section of the video we have successfully determined the gradient values of this node. Okay, all the gradient values that are associated with this node. Now let us try to determine all the gradients that are associated with this node. Okay, now let us see what are all the gradients that are associated with this node. First comes del L by del B21. Okay, del L by del B21 is the first gradient that is associated with this node, and let us see the weights that are connected to this node. Okay, the first weight is W112 and the second weight is W122. Okay, dou L by dou W112 comma dou L by dou W1 to 2. Okay, these are all the three gradients that are associated with this node. Okay, now we'll be seeing the indirect relationship. Okay, indirect and direct relationship parts of this node. Okay, of this node. First, from where you start from y hat. Okay, you start from loss. From loss you go to y hat. From y hat you will be going to as you're calculating for this node, you'll be going to O12. O12. Now, this O12 output is dependent on three trainable parameters, that is B12 and W112, W122. Okay, W122. First, you're starting with L, you're moving to y hat, you're moving to O12 output, and this O12 output is dependent on three trainable parameters, that is B12 bias, W112 weight, and W122 weight. Okay, these are all the three trainable parameters that are associated with respect to this output. Now by basing on this indirect path, we'll be rewriting this gradient values. Okay, you start with dou L by dou B21. This is equal to dou L by, I'm choosing this path. Okay, I am again choosing this path. Now with respect to this, dou L by dou y hat into dou y hat by dou O12 into dou O12 multiplied by dou B12. Okay, now let us try to find the individual derivatives. Okay, now let us try to find individual derivatives. First, you start with dou L by dou y hat. You already know the value of dou L by dou y hat, that is the differentiation loss function with respect to y hat, which comes out to be minus 2 into y minus y hat. Now I need to determine dou y hat by dou O12. Okay, now let us calculate the derivative value of dou y hat by dou O12, which is equal to we already know the equation of y hat, that is O11 multiplied with W211 plus O12 multiplied with W221 added with bias. Okay, now this comes out to be O11 multiplied with W211 plus O12 multiplied with W221 plus B21 bias. Okay, now let us find the derivative value with respect to O12. Now the derivative value with respect to O12 is, this comes out to be 0, this comes out to be 0, and the derivative value of this is W221, right? Okay, now let us try to calculate the value of this derivative. Okay, this derivative, that is dou O12 by dou B12. Okay, dou O12 by dou B12. Now in this derivative you see that O12. Okay, O12 is the output of this node. Okay, how the output of this node is determined, which is a multiplication of xi1 with respect to W112 and xi2 with respect to multiplied with respect to W122 added with bias B12. Okay, added with bias B12, dou B12, and I'm writing the same equation over here. Okay, that is xi1 multiplied by W112 plus xi2 multiplied with W122 plus B12 bias. Now I'm calculating the derivative with respect to B12. This comes out to be 0, this comes out to be 0. Derivative of x with respect to x is 1. Okay, this is equal to 1. Now I'm writing the same equation over here. Okay, now I'll be writing the same equation over here, that is dou L by dou B21 is equal to minus 2 into my minus y hat multiplied by W221 multiplied by 1. Okay, I have successfully determined the value of this gradient. Okay, now let us determine the value of this gradient, that is dou L by dou W112. which comes out to be this indirect path. Okay, this indirect path. Now I'm writing the equation with respect to this indirect path, that is dou L by dou y hat multiplied by dou y hat by dou O12 multiplied by dou O12 divided by dou W1 12. Okay, this is the representation of indirect derivatives. Okay, here I know the value of this derivative. I already know the value of this derivative, that is W221. Now I need to determine the value of this derivative with respect to W112. Okay, here I have calculated with respect to B12. Instead of B12, I need to determine with respect to W112. Okay, the equation of this O12 output is same, just I need to calculate the partial derivative with respect to W112. Okay, when I do the partial derivative with respect to W112, this comes out to be 0, this comes out to be 0, and I'll be left out with this term. The derivative of 2x with respect to x is 2, right? So similarly, the derivative of xi1 with xi1 multiplied with W112 with respect to W112 is xi2, so xi1. Okay, this entire equation comes out to be minus 2 into y minus y hat multiplied with W2 to 1 multiplied with sorry xi1. Okay, this is the final equation. Okay, this is the final value of derivative of this gradient. Okay, now we'll be determining the value of this gradient, which comes out to be the our last derivative value. Okay, our last gradient value. Now this indirect relationship can be represented in the similar way, that is this path. I'll be following now this path. Based on this path, the equation could be 1 2 is equal to dou L by dou y hat multiplied by dou y hat by dou O12 multiplied by dou O12 by dou W122. Okay, now I have already calculated the value of this derivative. Even I know the value of this derivative, only I need to determine the value of this derivative is with respect to W122. Here I have calculated with respect to B12, and the equation follows same. Okay, now when I calculate with respect to W122, this comes out to be 0, this comes out to be 0, this comes out to be xi2. So finally my equation could be minus 2 into y minus y hat multiplied by W2 to 1 multiplied by xi2. Okay, this is my final value of this gradient. Okay, my final value of this gradient. You can see that, okay, in the entire calculation of each of the gradient, you see that you always start from L, and you are reaching till your final weight value. Okay, final weight value, you are starting from loss. Okay, your main agenda is to minimize the loss. To minimize the loss, first you are touching the value of phi hat. Okay, when you touch the value of phi hat, it is indirectly touching the each of the parameters. Okay, each of the parameters, which is coming out to be until here. Okay, until here. So this is the entire back propagation algorithm. Inside the back propagation algorithm, the same calculation goes, and your weights and bias are updated for each of the forward propagation and backward propagation. Okay, this is the entire flow of back propagation algorithm. Okay, hope you like the video. If you like the video, please like, share and subscribe. Thank you. Meet you in the next video.